Hello and welcome back to another video. In this video, we're going to discuss all about uncertainty for A-level physics. Uncertainty is the difference between the measured or actual value, basically the one that is caused by the equipment or the technique that you're using, and the true value, the real value. Okay, it's different from errors because errors is caused by the equipment or method used, which gives reading which is not the true value. Uncertainty, however, is a range of values within which the true value is. For example, here the measured value is 15.50 and then it's plus minus 0.05 grams. That means the true value lies within plus minus 0.05 grams. Moving on, let's look at different ways to represent uncertainty. It's absolute uncertainty, fractional uncertainty, or percentage uncertainty. To do that, let's look at this voltmeter. It's millivolts, so it's voltmeter. If you look at the reading, it's 2.2, 2.4. So you can write this as 2.4 millivolts. What about the smallest division? It's 0.2, 0.4, 0.6, 0.8, and then 3, right? So the smallest division is 0.2 millivolts. Now, in order to find the uncertainty, we have to multiply the smallest division by half. Okay, when you have a device like this, for example, a voltmeter, ammeter, you have to multiply the value of smallest division by half. So this is going to be half multiplied by 0.2 millivolts, and the value is going to be 0.1 millivolts. So you can represent the uncertainty as 2.4, since you have 2.4 here, plus minus 0.1 millivolts. To find the fractional uncertainty, divide the uncertainty by the measured value. So this is going to be 0.1 divided by the measured value, which is 2.4. So you can represent this as 2.4 plus minus 1 by 24. To find the percentage uncertainty, just multiply the fractional uncertainty here with 100. So it's going to be 1 over 24. So you can represent this as 2.4 plus minus 4%. Now let's see how can you find uncertainty in different situations. First is from a reading. For example, a voltmeter, ammeter, or thermometer is going to be plus minus half into smallest division. This is just how as we saw here in this voltmeter. Now when we multiply this by half, how can you identify whether it's a reading or a measurement? For example, from a ruler. For a reading, you only have one measured value, which is this one. As given here, you're getting 2.5 millivolts. But for a measurement, you may have two values, the start and the end. For example, if you have an angle, something like this, and you need to measure it, you may have this, you're measuring two times, this one as well as this one. If you are measuring it from a ruler, something like this, and your object is here, you have to measure the starting value and the ending value, right? So this is going to be, you have two measured values, therefore the uncertainty would at least be plus minus the smallest division. So for here it could be 0.1 centimeter, plus minus 0.1 centimeter. We can reduce uncertainty by fixing one end of the ruler. For example, if this is 0 and we just keep our object here, so we are only measuring from one side, you have one measurement, so that will reduce the uncertainty. Another way to reduce uncertainty is, for example, in the swing of pendulum. Let's say you were measuring the time period of 10 swings. So this is going to be 6.2 plus minus 0.1 second. Now if you want to find for one swing, you just have to divide this by 10. This is going to be divided by 10, right? So it will be 0.62 plus minus 0.01 seconds. So you can see we divided the time as well as the uncertainty, so this is divided by 10. Now what if you have repeated data, for example 3.45, 3.5, and 3.55? That means you have a range of data. You're going to multiply half by range. The range is the difference between biggest and smallest value. So this is going to be half multiplied by the range. It is 3.55 minus 3.45. This is going to be 3.50 plus minus 0.05, and that's your uncertainty. In digital readings, plus minus the last significant digit. This is 0.1, one number after the significant figure, so we'll write plus minus 0.1 grams. or it's going to be explicitly mentioned on your device. For example, you can have an ammeter and it would say the uncertainty is plus minus 0.01 milliampere or ampere, something like that. Okay, it will be specially mentioned. Now, there are specific rules that you should know. If you're adding or subtracting, just add the absolute uncertainty. For example, if your equation is x plus y equals z or x minus y equals to z, just add these absolute uncertainty to find the uncertainty of z. Here we have an example, and the equation is z equals to x minus y. You're supposed to find the uncertainty of z. Z equals x minus y. This is going to be 6.3 minus 5, which equals to 1.3. And then you just have to add 0.1 plus 0.2. This is going to be 0.3. So you can write this as 1.3 plus minus 0.3 grams. What's the rule if you're multiplying or dividing? For example, z equals to x multiplied by y or x divided by y. Delta z over z equals to delta x over x plus delta y over y. And one example. So you have this equation, F equals to ma. Mass and acceleration is being multiplied, so you will follow this rule. Let's find the F first. F is ma. This is going to be 20 multiplied by 6. This is going to be 120. What about delta F? Delta F over F equals to delta m over m plus delta a over a. So if you plug in the values, you will get delta F over F is going to be 0.013. In order to find the uncertainty, you have to multiply 0.013 to the force. Force was 120. Okay, multiply this by 120 and you will get 1.6. So that's delta F. Now this is another important rule. What if you have a power? For example, z equals to x squared multiplied by y, or z equals to x squared divided by y. You have to write this power and multiply this. Okay, so delta z over z equals to, everything is same, delta x over x, delta y over y, but now you're multiplying this by 2. If, for example, this was, you had y cubed, you will multiply by 3. But what if you had a constant? For example, it was x squared times y cubed multiplied by pi. Pi, remember, constants have no uncertainty. So you're not going to mention the constant in your uncertainty, okay? You will only use it when you're finding the value of z. Just how we found the value of z here with the measured value. Let's look at example. Area equals to pi r squared. Find the uncertainty of A, where radius equals 5.00 plus minus 0.03 millimeters squared. So area equals to pi times 5.00 squared, 78.5 millimeter square. Delta A over A equals to, pi does not show up when you're finding the uncertainty. Power 2 is going to be multiplied. So this is going to be 2 into delta R over R. So delta A equals to 2 multiplied by 0.03 divided by the radius, which is 5. And then you have to multiply all of this by area, because this area goes over there. So that is going to be 78.5. Let's find this. This is going to be 0. This is going to be 0.9. So your area here is going to be 78.5. So area equals to 78.5 plus minus 0.9 millimeter squared. Now what if you need to find the percentage uncertainty? To find the percentage uncertainty, just multiply this by 100. So if you look at the above example, it's going to be absolute uncertainty, which is 0.9 divided by 78.5, the measured value, 78.5, and then just multiply this by 100 to get your percentage uncertainty. Next, okay, what if you have to do something like this? Find the fractional uncertainty of 1 by a when this is the value for a. Delta 1 by a over 1 by a, right? Just write the fractional uncertainty of a, delta a divided by a. Okay, So this is going, so delta 1 by a equals to delta a is 0.01 multiplied by divided by a, which is 2.05, and then you're going to multiply this by 1 by a. 1 by a is 1 divided by 2.05. This is going to give you almost 0.002. So you can write it like this. 1 by a is 0.488, because that is the value for 1 by a. This is a 0.488 plus minus 0.002. Now what if you have a question where you have both addition and subtraction as well as multiplication and division? To do that, if you want to find the uncertainty, find x max and then subtract this from the value of x max minus x. Let's say you have the value and uncertainty of a, b, and c. X equals 1 by a plus 1 by b. Let's find the value of x first. So x equals to 1 over 2.05 plus 1 divided by 3.0. This is going to be 0.8211. Now you have to find delta x. Find x max minus x. So to find the maximum value of x, you have to, in the denominator, you should take the smallest value, because if you have a small denominator, you will have a big value of x. So this is going to be 1 divided by 2.04. Now how did you get 2.04? Because remember, 2.05 plus minus 0.01. So the smallest value is subtracting it, 2.05 minus 0.01, and then you will get this smallest value. And then plus 1 divided by b. b is 3. So 3 minus 0.5 is going to be 2.5 divided by 2.5. So now you will get the maximum possible value of x, and then subtract it from the value of x, which is 0.8211. This will give you 0.007. So you can write this as something like this: 0.82 plus minus 0.07. Confused why did we use these values here? Remember this rule. If you want to have x max and you are going to be dividing it, you will have to take 1 divided by a, or a minimum. If you have 1 divided by 100, it's going to give you 0.01. Compare that to if you take a very small value, 1 divided by 2, for example, this is going to give you 0.5. Look, if you have a small denominator, you get a big numerator. That's why we take small value in the denominator to get the maximum value. Now this is when you are dividing. In the second example, now we are subtracting it, okay? C minus a by b. First, let's find the value of x. X is c minus a over b. 1.054 minus a by b, 2.05 divided by 3. This equals to 0.371. Now we have to find delta x equals to x max minus x. Okay, now you need to get the maximum value for this one. To get the maximum value, we'll take a large value of c, small number here. If you're subtracting large value of c with another small number, you'll get a big number, right? So we'll do something like this. We'll have c max, the big value for c, minus a min divided by b max. If you're confused why, we are subtracting, right? We need to subtract from a very small number. So in numerator would be small number to get a small value, and then in the denominator we have a huge value. This is going to give you a small value as well. So c max minus a min over b max, let's plug in the values. This is going to be 1.057 minus 2.04 divided by 3.5. This is going to be 0.4741. Okay, delta x is x max minus x, so 0.4741 minus x, which is here, 0.371. This is going to be 0.10. Let's write this as 0.4 plus minus 0.1. Okay. Now what if you have logarithm? If you have logarithm, do this. To find the uncertainty, find a log of x max minus log of x. For example, a is 512 plus minus 2. X equals log a. This is going to be x equals to log of 512, which equals to 2.709. So delta x equals to log of x max minus log of x. X max is the maximum value. So 512 plus 2. These values range from 510 to 514 because 512 plus 2 is 514. 512 minus 2 is 510. So maximum value is 514 minus logarithm of x, which is 2.709 already given here. So this is going to be 0.002. You can write this as 2.709 plus minus 0.002. 3 decimal points and 3 decimal points. So that's your value. Now what if you can apply the same thing for ln? X equals natural log 1 over a. Let's find the value for natural log 1 over a. So x equals to ln 1 divided by 512. That will be negative 6.238. Delta x equals to ln x max minus ln of x, right? So to find the, in order to get the maximum value, you need to have a small value in the denominator, right? So this is going to be 1 divided by 510 minus 6.24. So this is going to give you 0.004. You can write this as 6.238 plus minus 0.004. We have 3 decimal places, so we have 3 decimal places here as well. Moving on, what if you have graphs? Okay, to find the uncertainty of graphs, you can do that. If maybe you can find it using gradient or the y-intercept. You will be asked. Okay, to find the uncertainty with the gradient, it's going to be the gradient of best fit line minus the gradient of the worst fit line and the absolute value. It cannot be negative. It should not be negative. Then divide this by the gradient of the best fit line. Multiply this by 100. Same thing for the intercept. Y-intercept of best fit line minus the y-intercept of the worst fit line, and then divide this by the y-intercept of best fit line. How do you draw these best fit lines? For example, if you have a graph and then you have your points, okay, the line that goes through most of the points is the line of best fit. To draw the worst fit line, you will draw your error bars. For example, if it's plus minus 0.1 centimeter, you will draw it on either side, 0.1 on both sides, okay, like this. Let's say this is centimeters. And then your line of worst fit would start from, could be something like this. The worst fit line would be from this edge of the error bar to the other edge of the error bar. That's all.